Hello. Welcome to PyExcellence Tutorials with your PyExcellent tutor. And today we are going to look at rockets. This is different. The past two videos, the previous two videos, we looked at the elevator. But this time around, we're looking at the rocket. So we have a rocket of mass 5 by 10 to the power 4 kilogram, which is in flight. Its thrust is directed at an angle of 60 degrees above the horizontal and has a mass of 7 by 10 to the power 5 Newton. Find the magnitude and direction of the rocket's acceleration. Give the direction as an angle above the horizontal. So we're going to have a situation like this one, where we have, let this be the rocket. So this rocket is flight, and then we are told that thrust is, so let's say this is horizontal, is directed at 60 degrees. So thrust, just basically put FT, okay? So it's directed at that. So the free body diagram showing the forces now, we are going to be able, because this thrust is directed at an angle. So we need to be able to resolve this force in components in X, because we know that it has got in X and also has got a component in Y. So now, if that is the case, what we are going to have, we're going to have a system like, if this is our rocket, we are going to have the Y component, we're going to have the Y component of thrust, which is going to be thrust sine 60. And then we're in the same way, we're going to have the weight of this rocket, which you will just note mg. And then in the horizontal here, we are going to have the component of thrust in the X direction, of which is going to be thrust cos 60. Okay, so that is what we are going to have now. So even the acceleration, we are going to have the two components of acceleration, of which we are going to find the magnitude at the end. So we can say acceleration in the X component of acceleration is going to be the component of thrust in the X of the mass of the rocket. So we have 7 by 10 to the power 5 cos 60 over 5 by 10 to the power 4 kg, and this is Newton. Okay, so once we punch that, we get 7 meters per square second. So that's the component of acceleration in the X. We get to the component of acceleration in the Y. Now, if you check on the diagram, we are going to see that we have two forces acting in the vertical. So we have the Y component of thrust and also the weight of the rocket. So they are even in the opposite direction. So if we take upwards to be positive, we're going to have the y component, vertical component of thrust minus mg over m. So this is basically 7. Okay, so I'll write this here. So we have 7 by 10 to the power 5 sine 60 Newton minus the mass, which is 5 times 10 to the power 4 kg, multiplying by the gravitational acceleration 9.81 squared. And our mass is 5 times 10 to the power 4 kilogram. So that is going to give us going to give us 2.3 meter per square second. So that is also the y component of acceleration. So now we get to find the magnitude, and we know that the magnitude, we find it by that equation, which we substitute. We have 7 squared plus 2.3 squared. So our acceleration is going to be going to be 7.4 meter per square second. So that is going to be our acceleration. And then we also multiply we also find the direction. We've been asked to find the direction also of this same acceleration. So for finding the direction, we use the tangent. Cotangent. So we have tan theta so we have theta being equal to the inverse of 2.3 over 7, and then that will give us that gives us 18.2 degrees. So this is how you find the direction of this acceleration. I hope you enjoyed the tutorial. Hope to see you next time.